Hello, welcome to More with Matrices. 8.4, Determinants. Determinants are just these special values that are only for square matrices. We'll also think about triangular matrices and square matrices and determinants of 2 by 2 and 3 by 3 and n by n matrices. Let's do this. Let's get this all focused and set up. Very nice. Here we go. Okay. What is the determinant of a square matrix and how do you find the determinant? All right. Make sure you're taking very good notes, and sometimes you may use a calculator, but not for this particular lesson, okay? All right. So how do we find the determinant of a square matrix? Once again, square matrices are matrices that are n by n. Right? The order is n by n. That means the number of rows and number of columns are equal. All right. So let's first start with every square matrix can be associated with a real number called a determinant, a real special number, right? And there's a lot of these are special. It's a special number. Okay. It's a special number, and it could do magic. There's a lot of applications. Like we can find area of triangles with these special numbers. You can also see if these points or these points are collinear. Do you remember where collinear points are? If all points lie on the same line, we can actually determine that with determinants. So it helps us determine a lot of things, okay? That's a good way to think about it. So let's try another one. Let's do some, okay? Use of determinants can arose from special number patterns that occur when system of linear equations are solved, like this one. So you're used to solving these kind of linear equations, right? You have ax, plus by equals c1, a2x plus b2y equals c2, and then you do your little magic, how do you solve this linear system when you first learned it in Algebra 1? You maybe try to get rid of the x variable by making these opposite, right? You try to maybe get rid of the b's or the y's so you can isolate the x's and solve for c, right? You did all that, right? Well, you know that when you actually do that, try solving this, right? Try solving by eliminating the x. See what you get. Well, when you try to do that, you actually get these solutions here. These solutions here. Interestingly. Now, I'm going to show you better in class how this is all related. And you know what? Why don't you try to see if you can come up with this and this. For example, how did we get this x? We got this x by trying to eliminate the y. If I was trying to eliminate the y, what would I do? I'd multiply this whole row by negative b2, because then I would have negative b2 times positive b1. That would be negative b1, b2. And then I would multiply this sucker by negative b1, positive b1, because then they would be opposite and I would eliminate the y. If you didn't understand that, that's okay, but try. If I multiply this and I added them together, then I would actually end up with this if I were solving for x. Same thing for y, and these would be the solutions. And this has something to do with determinants, and you'll see that really quickly, okay? Also, I have to mention that a1b2 minus a2b1 is not equal to 0. Okay, I have to disclose that, okay? Now, do you notice something in common? Well, what I mean is, do you notice something in common between this and this here? Do you? I hope so. What you should have noticed is the denominators are the same. So that's something special that you should have noticed. The denominators are equal. Okay. I wonder what that means. Okay. So we're going to now try some. So we're going to move on to the next. All right. Now, part 1, determinant of a 2 by 2, the most basic case, a 2 by 2. That's the easiest, and we use this a lot. Okay. The determinant of a 2 by 2 matrix. Here we go. Given a matrix A with A, B, C, D as its elements, written either. You could write either determinant of A, like this. You can actually write it like this, determinant. You can spell it out, A. Or you can write these straight lines, kind of like absolute value signs, but try to make them longer than maybe an absolute value sign. Especially if you put it in a matrix, then we understand that doesn't mean absolute value. It's a number defined by the following of this. So watch this. Dun, 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 dun. So determinant of A is equal to the determinant of A. They're all the same meaning. And when you're writing a matrix and you're calculating, so you're computing a matrix, a determinant of a matrix, then you put these straight lines, not a square bracket anymore. What you do is you multiply AD and you subtract that from, subtract BC from AD. So you go AD minus BC. And that's how you get the determinant. Strange, I know. So let's try that really quickly, okay? So we're going to find the determinant of a 2x2 matrix. So here's my matrix C. If I'm going to find the determinant of C, what do? I simply go, I'm trying to find the determinant of C, or you can write it as determinant of C is, I would go 0 times 4, A minus D, A times D, minus B times C. A times D minus B times C. And what do I end up with? I end up with -3. And that's the determinant of C. So I would say determinant of C is -3. And we do cool things with this, so keep that in mind, okay? All right, we're going to move on to part 2. All right, that was quick, huh? That was quick, okay? All right, let's move on to part 2. Now we're going to find the determinant of a 3x3. Now that gets a little bit trickier, so make sure you watch out for the next video.